They're all distinct, and there's actually there can be a fourth, and that's why I think it's so interesting here. So ordinal is numbers like 0th, 1st, 2nd, 3rd, 4th. So what's important about the numbers is that they have an order. Like 6 is really there to be after 5 and before 7.
Right.
You know. Then there's cardinal numbers. So that's 0, 1, 2, 3, 4. So a triangle has 3 necks. You know, the things that are true about a triangle are true because 3 has a certain nature to it. You know, and a tetrahedron is the simplest 3-dimensional space because of the properties of 4 and 6 and 3 and how they all kind of come together to form a tetrahedron. So that's the cardinal values. And then there are the nominal values, you know, and that is like a partridge in a pear tree, you know, 4 calling birds, 3 French hens, 2 turtle doves. So you can use a number to represent another thing, you know, another string, and it's kind of like a form of compression. And we make very heavy use of nominal numbers. This recording is just a bunch of nominal numbers. It's numbers being used to represent other things, ultimately. And that kind of like nascent fourth property is numbers in an operative sense.
What?
Numbers in an operative sense. So, and
the fourth thing is numbers in an operative sense.
Yeah. So, if you want to add, you know, 0, 1 to 2, you have a plus. You know, 1 plus 2, and the plus is some magic thing that's not a number that allows you to perform the operation of addition on 1 and 2.
But you're calling that a number?
But if you take a particular kind of data structure and you say, if a 1 is found here, and a 0 is found here, and a 2 is found here, that 0 means add the 1 and the 2 and return the value 3. You know, and the multiplication could have the number 1, and division could have the number 2.
Yeah.
Right, and so you can have an automaton machine that using only numbers and a very simple data structure to hold them will perform the transformations that you can perform on a number. So you
Does that mean it's possible to find out which kinds of operations go with
that's
which?
That's what knock is. That's what the Urbit virtual machine does exactly this. It has
progressively.
Yes, exactly. It's just a series of string reductions. So you write out a data structure composed of numbers, and it takes a number that's in a particular position in that data structure and follows the very simple reduction rule that number implies, and it does it over and over and over again until there's no more reductions left, and that is the result.
So do those rules change? Which rule is associated with which number over time?
Yeah, no. The rules are the same. They're opcodes.
Oh, basically. They're the 10 operations.
Yeah.
Okay.
Yeah.
Cool. All right.
And then, in a looser sense, this is what a computer chip does, because so like you know, an assembler word is turned into a machine language word, which is just a number, and that number ends up in a register, and the machine sees it, and it says, okay, what I should do is compare these two numbers, and if they are the same, then I jump to what's in this register. If they're different, then I jump to what's in this other register. You know, that's all. It's interpretation of the number as an operation on the rest of the mathematical system. So we might call that the operative.
The fourth. Yeah. Is there any necessity to the 10 operations, what they are, and why those 10 were selected?
Glad you asked. So that is why I developed AX. Is because AX is an attempt to write an operative specification for the simple natural numbers that is in harmony with their other properties, in particular their cardinal values, but also their order. Because in knock 000, which is the simplest possible minimal program, is not illegal. It's a legal program that produces the value 0. And the program 0100 produces 1. Yeah. 0101 produces 2.
That makes sense.
2121 uses the 2 operator to produce 3. And so that...
Quite amazing.
Yeah.
Yeah, we should maybe work together. Like,
Oh, excellent.
Yeah, I'm writing a book. I'm writing a book on the numogram called Unleashing the Numogram.
Like the Enneagram numogram?
The numogram from CCRU.
don't remember this thing.
It's like their primary product. They
had a product.
They produced the Numogram and all the mythos.
You show him a picture of the Numogram.
Yeah.
I've been working backwards towards CCRA.
I have the
found
other half
Loper.
of this.
Through Loper, I found unqualified reservations and Urbit. Through that, I found Xenosystems. Through Xenosystems, I found the CCRU and Xenofeminist.
By the way,
but only just very recently.
Oh, okay.
Slinging a bunch of aluminum dust in the air.
Oh, excellent. All right, this is over. Show him.
Over?
Yeah, it's in the video and show him the...
Oh, yeah. So, but just say, what did you say again? Just say one more time, because I didn't hear.
Oh, geez.
You found something first.
Right, I found Loper OS. He's a writer about computer programmers, and he wrote about Urbit.
Okay.
And through Urbit, I found unqualified reservations, and then I found Nick Land.
Yeah.
And then I sort of back-worked from there to CCRU and Xenofeminism, but only just recently.
Cool. Oh, okay, cool. I'll
still a lot to
send you
pick
my
up.
notes. Yeah, let me...